Okay, some more problems in section 4.6, and I'll try to graph two periods in these two problems because I wasn't doing that in the other ones. And again, we're going to start over here with our reference function. In other words, this is the one we're going to graph. We'll graph that in black, and we'll use the reference function in orange. This is the 2 cosecant of pi x. So this, I'm going to use a negative 2 cosecant of pi x. So I'll graph, first of all, y equals negative 2 sine of pi x. I got to figure out the period. The period is equal to 2 pi over b. And that's going to be 2 pi over, and b is just pi. So my period's 2. And if I want to see my subdivisions, 2 divided by 4 is 1/2. So they're going to be 1/2. And I'm going to want to graph two periods, so I'm going to have to go to 4. So when and my amplitude is 2, so I'll have to do this over here. So make sure I don't go down too far. Let's see, like this, try it like this here. And we'll go, okay. And we'll just call this y x. We'll call this 1, 2, negative 1, negative 2. And we'll call this, we're going to go all the way out, we'll call this 4. And then we'll call this 2 here. So this would be one period, so I'll divide that into halves. First of all, that makes that 1. And this would be 1/2, 1/2, and 1 and 1/2, 3/2. And I'll divide this one up for the next one. And that'll be 3. And I'll just put some markers here because I'm going to see how that goes. Okay? And so let's graph this. The period is negative 2, so sine starts at 0, so that doesn't matter. The zeros would be the same and everyone's 0. So I could put every one 0, every other one is 0, 0, and even over here. That's nice about the sine. And now the first subdivision, remember we usually go up to 1, but in this case we're going to go down to negative 2. And then once we do that, you can see the pattern. This is going to go up. And then we do it again over here. We normally go up to 1, but in this case we're going to go down to negative 2, back to 0, so you can see that. So those zeros really help put those in. So I'll graph this. There's one period, and here's another one. There you go. So there's your two periods of our reference function. Remember, every time there's a 0, I have asymptote because 1 over 0 is undefined. So every time I see a 0, I'll put the asymptotes in. There you go. Okay. So now we can put our function in, and that's going to go like this. This will be our cosecant. I reviewed some of my work up here as usual. Sorry about that. And there you have it. And then I want to get my asymptotes to go a little bit higher so I can, because I brought my curve up. There you go. That's pretty cool. Look at that. Okay. Hope that makes sense. Alrighty. And 39. Again, this is going to be our reference function. So, well, we got the same period. Okay. In other words, period equals 2 pi over b, which is 2 pi over pi, so it's going to be period's going to be 2 again. And this is going to be negative 1/2, so my amplitude won't be so high, so that'll be a little bit easier. I can even use, I'll probably use the scale anyway to scale it down a little bit. So let's draw this axis here. Now on the cosine I want to go a little bit more because I'm going to have to like lap it over. So I'll call this maybe 4 over here. That looks like that'll be about right. And then half of 4 is 2. There's 3. There's 1. And these are my subintervals there. And I'm going to put one more here. So that'd be 4 1/4. I'm sorry, 4 1/2, pardon me. Because each of these is, if you divide that by 4, you get 1/2. So this would be 4 1/2, 1/2, 3 halves, 4 halves, 5 halves, 6 halves, 7 halves, 8 halves, 4 1/2, 9 halves. Okay? So we got our axes done. Now this is y, this is x, this is 1, and this is -1, so this is 1/2 and -1/2. And we have -1/2, so that's going to make it a little more complicated. Okay, so this is one period, one cycle. So we start the cosine usually on 1, but we're going to multiply that by -1/2, so we're going to start here at -1/2. And then we go here, 0, up, 0, and back to the beginning. And then you can follow the same pattern. Up there, okay. Again, one more. And there you go. So it starts like this. Looks almost like a roller coaster, right? Yeah, like a nice bumpy roller coaster. All right, so there's our 2 periods. This is one period. We start here and end there, and then start there and end there. So that's a little bit more even than 2 periods. Okay. So again, normally it would start at 1 and would go like that. But we're going to multiply by -1/2, so it starts at -1/2, and then we just follow the same pattern. And again, we'll put our asymptotes in. Every time there's a 0, that's an asymptote, because 1 over 0 is undefined. Let's see here, we're doing good. And this is why I did a little bit extra, so I could get another full like pattern over here. So there we go. Alrighty. Goes like that, and this one goes up here. And here's the last one. There we go. Alrighty. And if you wanted, you could show part of this one here if you wanted to do that. So you get an idea. So something of that nature. You could probably hug this a little bit better. But I'm just sketching these out pretty fast. Okay. I hope that makes sense. And that's a little bit more. There's 2 full periods there. There's a little bit more even. Okay. That's 39. Hope that helps.